Hello, ladies and gentlemen. I'm going to show you how to find everything you need to calculate the tipping force for our 5.8 yard art design challenge. So, to see whether we meet the required tipping force of 50 pounds or not, you're going to need the weight of your object in pounds, the distance of the center of gravity from the y-axis or the side that it's tipping from, and the height that the tipping force is applied from the bottom of the object. So let's get to that. We're going to start by finding the weight. So here's my brief object that I've made in Autodesk. Just for those of y'all that don't know, once again, I've got to change my material to wood. Forgot to do that earlier, so I click this drop down and I scroll down to the types of wood, and I'm just going to choose birch. Why not? Okay. So, find the weight of my object. I'm going to File, My Properties. I'm going to move this over, Physical, Update. All right, and here's all my eye properties. Now, for those of y'all in my class, I want you to actually take a screenshot of all of this. You're going to print that out, put it in your notebook, and you're also going to save the screenshot of all of this for later. Okay, so make sure that you save this on a flash drive or something if you are in my class. So we have the mass right here, 0.101 pounds. Note that I did not make this necessarily at a correct size. This is just an example, but here's the mass of my example. The next thing that I want to do is find our center of gravity and the height of the tipping force. I'm just going to go ahead and show you height of the tipping force from the bottom of the object. So if you look at the design brief, it says it must not tip over when a force of 50 pounds is applied at the top of the body of the animal. So what I'm going to do is go to the Tools tab and use my Measure tool. All right. The Measure tool can measure distances between many different points. There's two ways to go about this. I'm either going to click, see how this line highlights here, and then not the entire thing. I just want the edge here to here. Our minimum distance between those 2 points is what we want. See how that's 1.927 inches. The maximum distance is the furthest possible distance between those two. Another way that I can do this, since I have a flat object, I can click the top surface and then a very bottom surface. Once again, notice that our minimum distance is 1.927 inches. So that is the height to the location that the tipping force is going to be applied to the bottom of the object. Next, we need the distance of the weight from the center of gravity. So we have to do this. Now, if you have properly set your object against the origin, it is possible to find that in the eye properties, physical, and you see your center of gravity here of 0.645, but your tipping point has to be set correctly. Honestly, I prefer doing it this method anyway. Go to View, the View tab. Click right here in the Visibility panel, Center of Gravity. Notice that now the center of gravity for this object is turned on. And if you see, there's different planes. Well, we're going to do the same thing that I did before. I'm going to use the tools. I'm going to measure. I want this y-axis or vertical axis center of gravity. So, and you've got to make sure that it's the one that's actually highlighted, and you know that it's highlighted when it has these little circles around the corners. Clicking the y-axis center of gravity, and then I need to go to where it's going to be touching the ground and the outside edge, okay? So I don't want to have the entire thing highlighted. I just want this outside edge highlighted because that's where it will tip from. All right? Notice that I have now a number, our minimum distance of 0.742 inches. So that is the distance from the outside edge, the tipping point, to where the center of gravity is. That is the horizontal distance or the perpendicular distance, 90-degree angle. That is going to give you this number. That will give you our center of gravity. All right. So I hope y'all can use that, figure out your formula, find out if it's going to be able to withstand the tipping force. Remember that if it does not hold up to the tipping force, you don't have to necessarily go and redo it at this point in the project. You just need to explain where you didn't meet your parameters and how you could fix that. Thank you very much.